Hey everyone, today we're going to talk about the question, get keys in binary tree layer by layer. So for this question, we will have a binary tree like this example 1, 2, and 3. And we want to print out all the keys of the node from each layer to each layer. So for this example, the answer we want to get is 1, followed by 2 and 3. So let's do some clarification for this question. We can see the input type gonna be a tree node root, and the output type gonna be a list of lists with integer. So like 1 and 2, 3, and they are in one list. Let's assume the tree node root is not nor, and I'm gonna use a BFS way to solve this question today. So I'm gonna need to maintain a queue structure with the tree node in this queue structure. Every time I spend one node, I'm gonna generate 2 children nodes and offer into the queue until I don't have any node left. So the time complexity for this question is gonna be O(n). N is the number of nodes. Every time I have a node, I want to get the key of this node, and that's it. It's an O(n) time. So all of the nodes gonna cause a O(n) time. And for the space complexity, as we can see here, I have used a extra data structure called queue. So in the worst case, the queue structure maintains the maximum n numbers of nodes in the queue. So worst case is O(n) space complexity. All right, let's write the code now. So like we said, the output type gonna be a list of list integer, and we call this function integer. We call this function layer. Okay, the input type gonna be a tree node root. All right. So in here, we can see what we want to return is a list of list integer, and to implement this data structure integer, we're gonna need to use array list. Okay, array list. ARAY list. So let's do a sanity check. If the root equals to nor, I will return just an empty list, and here is the result. And then step 1, and step 1, maintain queue structure, which stores all the nodes that is visited but not generated yet. So it's a tree node structure. We call it queue, and is new implemented by a array stack. And first of all, we offer the first node into this structure, which is our input root. And then we're gonna use a while loop to scan all the nodes in the queue, and get the key of the node. So while the queue UE is not empty, in here we want to do a following steps. We want to maintain a list of integer, which is all the keys in one layer. We call it cur, coming from an array list as well. And another variable we want to keep is size, which is the queue size. The size here, means how many nodes we have in every layer. Okay, once we get this 2, I want to add all the valid keys into cur layer. So for size times, while int I equals to smaller than, so for size times, adding the keys into cur. Okay, so in here we have to pull out the first node we want, pull it out, and add the key into cur. So node.key, okay, adding. And then I expanded one, I want to generate 2 children. So if node.left is not nor, we want to generate this child into Q. Q offer root, not root, node dot left. And same for the right child, node dot right is not nor. Okay, generate this one into Q as well. QE offer node dot right. Okay, this is a for loop. So after the for loop, we should get size. We should get size of curve. We should get entire curve, and we want to add all the key values, all the keys in the curve. So into this result. So result add all the curve we have for each layer. And this is the while loop, close. After the while loop, we should have all the keys that added into curve and curve added into results. So we return results here. Cool. So that is the solution for the question. Let me know if you have any question or following ups, and I will see you next time.